Hello and welcome to our virtual Lunch and Learn today. We're talking about safety trends with Rockwell Automation Power Products. And my name is Rachel Green. I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today will be Lee Smith, Drives and Power Consultant out of our Charlotte, North Carolina branch. On the comment section, ready to answer your questions, is our systems consultant, Les Smith, no relation, out of our Toledo, Ohio branch. We'll also have a Q&A portion at the end for Lee to answer your questions in more depth. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comment section. Hi, Les, I see you out there already. Thanks for tuning in. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist, and we cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. For anyone just coming in, welcome to our virtual Lunch and Learn Safety Trends with Rockwell Automation Power Products. Let us know where you're joining us from. We'll be looking for your questions in the comment section as you have them. And Lee Smith will talk to us about how to optimize your machine safety solution with Rockwell Automation's PowerFlex drives and intelligent motor control centers. Our specialist, Les Smith, is ready to respond to your questions in the comment section as we go through. And we'll also have a Q&A portion at the end of Lee's presentation. Hi, Jody. Thanks for joining. If you'd like to reach out afterward, or if you have further questions for Lee, you can always send us an email at the email address there on the screen, macamaclive@mc-mc.com. Just be sure to let us know which session you attended, and we'll direct your questions to the presenter. We'll have that email address on the screen at the end of the presentation for you as well. And it looks like we have a number of attendees with us. Hi, Ben. Hi, Leanne. Thanks for joining. So Lee, I'll pass it over to you now.
Thank you, Rachel. Good afternoon, ladies and gentlemen. I hope that you are safe and having a great day. So why machine safety? As we will learn, safety is becoming a vital part of system design. Properly designed safe machines have been found to increase productivity, reduce mean time to recovery, and improve competitiveness. But truly the most important of these and the largest cost savings has to be in reducing injuries. Let's take a look at some information I found from the National Security Council. So the latest data was from 2018, and it showed that work injury costs in 2018 totaled $170.8 billion. So that's $1,100 a worker. That's over $1 million per death and $41,000 per injury. And lost time, you're looking at over 1 million days of lost time, 70 million days due to injury, 33 million days due to injuries in prior years, and 55 million in future years, just from lagging, injuries that linger on and you have to continue to go to the doctor. So safety has become a higher and higher priority. A little over a year ago, a study done by the Aberdeen Group showed a clear relationship between safety and productivity. They found that the top 20%, the best in class, had 5% higher OEE, or overall equipment effectiveness, 4% less unscheduled downtime, and many fewer accidents, 1 in every 2,000 employees versus 1 in 111 employees for the average companies. The difference between these performance levels and average manufacturers was achieved by doing 3 things differently. First, they developed a safety culture where everyone had to buy in for the implementation of effective safety systems. They then formalized a risk management process to identify, prioritize, and mitigate the risk. Last, they invested in technologies to improve both safety and productivity. This is the area we will concentrate on today. So what I hope to achieve today is to show you how Rockwell Automation Power products, such as PowerFlex drives and IntelliCenter motor control centers, can help your company become one of these top companies. Rockwell has been committed to safety for a long time and continue to come out with new and innovative products. To see where Rockwell is heading, let's first see where they started, or where, kind of the safety aspect started. In the early days, manufacturing plants were extremely unsafe. This picture, sad to see kids up on machines, but safety, I think, has come a long way since then. And although some laws were in place for workplace safety, it wasn't until OSHA, or Occupational Health and Safety Administration, was formed that real safety regulations began to take form. For drives, the first true safety regulations look something like this antiquated old drawing that I pulled from a PowerPoint many years ago. For highest levels of safety, they wanted to see a redundant contactor system. In case one contactor happened to fail closed, this configuration could have both contactors on the input of the drive, or it could also have the contactors in series on the output of the drive. Either way, these configurations require a lot of wiring, multiple points of failure, and these designs can also shorten the life of a drive. A chattering contactor on the output of the drive can absolutely take out the IGBTs or the power transistors on the output of the drive. And operators sometimes get in the habit of using the e-stop as a cycle stop. And in the case where the input contactors are repeatedly turning the drive off and back on, this can take out the pre-charge circuit in the front end of the drive. And pretty much anyone's drive out there says not to turn the drive off and back on more than once a minute. So, these configurations, while they did help make the machine safe, they were not very good on the drive or for troubleshooting. But since the early 2000s, some of our drives could be ordered with a basic safe torque off circuit or an add-on module. Some of our PowerFlex 70, 700, the PowerFlex 40Ps. This circuit would allow, in most cases, for the safety contactors to be removed. This allowed for less points of failure, less items to troubleshoot, lower total cost, and a much better drive life. Still had quite a few components that we'll look at in one of the slides coming up. Rockwell's newest drive lines have this safe torque off capability at either a minimal or no additional cost to a customer. We do this with the installation of a safe torque off card in the PowerFlex 753, 755, and 755T. That's the 20-750-S card. We also do it with the PowerFlex 525 and 527 through built-in hardwired safety. And in both cases, there are a couple of jumpers to remove. One for the safe torque off card is a red jumper on the main control board, and then a jumper in the 525 and 527. So just keep that in mind. So just a little bit more detail on what is going on in the safe torque off circuit. Safe torque off disables the drive's IGBTs by breaking the link with the drive microcontroller. And it does this with some redundant technology that enables it to meet 13849 and 62061 in your safety requirements. It does say in fine print to make sure that your safety relay and drive are in the same enclosure. So as you can see in this drawing, and this is really one of the most basic configurations, is category stop 0, coast to stop. You still have a lot of wiring from your guard switch out to your safety relay. You have wiring in from the power supply on your drive into redundant held closed relay contacts that then have to feed back into the safe torque off circuitry and the drive. This shows a 525, but the circuit is very similar for doing this with the 750 drives as well. So along with the push to build safer machines, the automation world was moving to make smarter machines as well, going away from proprietary communication platforms and hardwired control wiring. Management wanted more data that could easily be gathered, as well as faster, safer machines. Rockwell took standard Ethernet protocol, added layers of security and reliability, so that we now can use one standard network to do multiple things. And this is Ethernet IP, which is industrial protocol. So a good example of this in showing a smarter machine is pairing a compact Logix or a normal control Logix processor with a Stratix managed switch. Could be a 5700 or 8000, along with PowerFlex 750 or 520 drives on Ethernet. So in this example, something happens middle of the night, catastrophic failure, power surge, takes out a drive. In past, you would probably have to go and find the right guy that knew how to program the drive, find the right computer, the right cables. But in this scenario, whoever is changing the drive really just has to remove power and Ethernet, install the new drive, the Stratix managed switch can assign the Ethernet IP address. The controller, through a feature called Firmware Supervisor, can flash the drive to the correct firmware if it happens to be at a different level. And then the controller will, through a process called Automatic Device Configuration, we also call it ADC, can have the parameters stored and push those parameters into the drive. So great features just in our standard operation. So now we are seeing that these smarter machines can also be safer machines. This network that we're showing enables us to have sensors that tell us when they are dirty, have light curtains that can know which beam is broken, and drives that can tell you when the cooling fan needs to be changed. This natural progression is making machines smarter and is leading to the same technology in making them safer. A key component to this is a safety rated controller. Here I have a couple of examples of modern safety controllers in the compact Logix family. that cover most of the machine safety applications out there. And there's always full guard logics to cover all the rest. And I have seen that these controllers really have come down in cost from where they were 5 or 6 years ago. You get a lot of power for not a whole lot more money than a standard controller now. This particular compact GuardLogix 5380 family, we can do, depending on the processor, up to 32 axes of motion. We can do 1 gigabit embedded Ethernet, so really high speed, and up to 180 nodes of control of different devices out there. We can reach SIL 3, PLE, and Category 4 with certain versions of these processors as well. They have conformally coded versions and very enhanced safety features and security features for that safety. With these safety controllers, we can now open up a ton of capability for both standard and safety control. By putting items like drives, light curtains, and gate controls on an Ethernet IP network, we eliminate a huge amount of wiring and setup. It also gives us, a single controller to do standard and safety control. A controller that we're already programming in and familiar with. It gives you a single software for doing that same kind of programming. It's a very similar look. When you use a safety controller, you'll add some safety tasks, main routine. Those can be password locked, so not just anyone can go in and change how the safety routine works. So just a ton of flexibility and capability. There are over 100 instructions already pre-built, and there is a capability to facilitate designing your own add-in instructions as well. So just an example of how a safety system can look even today. You go out and buy a locking door switch with a solenoid, may have some kind of enabling hand switch, key switches, separate safety button, and then safety encoders over here. Now, through an integrated safety platform, you have a controller, have a switch, same Ethernet running out to these devices, but now with just powering this guard switch up, we can lock, unlock, we can get the information back in a complete, safety platform. Another good example of what we can now attain with safety over Ethernet is this safe limited speed that we can do with drives, and we'll talk a little bit more about that card in a few moments. But this example shows, the drive is running along, going through its process, and someone sets off this safe limited speed request. Could be from a light curtain, could be from the guard switch, a safe stop, or a safety mat. And the drive will go into a deceleration and go to whatever the safe limited speed is. It checks that speed to know for sure that you're running where it's a safe area for the operator to be in. Might be a roller on a printing press that you need to clean the ink off of, or some kind of a cutter that the blades need to be cleaned. And instead of having a hand turn something like that, you creep it along at 1 or 2 RPMs, allows the operator to get in and then get back into a safe zone, and the drive goes back up to speed. So those are some ways that we're really seeing you improve machine cycle time. You can use less floor space because you don't have to have as big a guard structure, greater system yield, and obviously the operators like it. They don't, not having to do as much, not as much repetitive injuries. So just some great capabilities that are now out there with these safety features. So this slide is kind of going over the differences and what you could have been using in the past. The 2750S card that I mentioned in the beginning has a good bit of hard wiring that has to go connect to the sensors and into the guard, or an e-stop into the relay. And then we have to make the connections from the relay out to the drives. And with the 2750-S3 card, we now can eliminate that wiring because we already had the Ethernet connections that were there. We drop the card in, we do the programming and the guard logics or compact guard logics, and we no longer have to have this separate relay. So really, a lot of areas that it helps with, reduce your hardware and your points of failure. That's a big one. It's field installable, so it can be added to existing 755 drives that you have out there. You can reduce your panel footprint with less wiring, less safety relays that have to be in there. You reduce your hardware and wiring and labor cost because there's less things to connect. And again, you have one node for safety and for the drive. You're not adding another Ethernet network or another IP address. You're running over that same network. And just, really flexible control like I showed with the safe limited speed. Another nice feature is that the configurations are common across the different devices that we can run on a SIP safety or safety over Ethernet network. So when you pull up in Studio 5000, the add-on profile, it will look very similar to a PowerFlex 527 and a Kinetics 5500. The PowerFlex 527 I'll talk about in just a little bit. It also has the ability to do safety over Ethernet. So that's just really nice common configuration programming and safety related tags. So some of the fine print for using the 2750 S3 card, it is not compatible with the 753. The firmware of the 750s need to be version 13 or higher. 755T came out around the same time as this, so at version 1 you can use it, and then the add-on profile needs to be new enough to recognize these safety cards, so version 4.09. Another biggie is version 30 of Studio 5000 or higher, and the controllers for the safety need to be L3S in the compact guard logics or L7S in the standard guard logics or higher. The card can react as quick as 15 milliseconds, lots of certifications, and automatic device configuration that we talked about. No need to turn that on or use with this card because it's automatically going to be getting its configuration from the safety controller at any time that it might be changed out. The there, as I said, the S3 can be networked, and it can also be hardwired. So it does have the capability of doing both, which is nice. It as a category 0 coast to stop or category 1 ramp to stop can be achieved with additional programming in the controller. The SIL ratings are 3 PLE and up to category 3. And as far as Ethernet port, the card does not have an Ethernet port because it is being paired with a 750 that we are already using, and it uses that through the backplane of the drive. Device level ring, the DLR, it does have that capability if you add a dual port Ethernet card to a 750 drive. We can run this in a standard IO mode, and this integrated motion mode is now available for the S3. Only put the card in ports 4 through 6 and port 4 or 5 in a frame 1 drive. So spoke a little about the PowerFlex 527. As I said, it does have similar capabilities as the 755 with the S3 card. The nice thing is it has built-in hardwired Ethernet here that you can use, or you can hook it up and program it. If you have a compact or a safety controller, you can hook this up on Ethernet as well. Has a nice built-in display, can do safety to SIL3 and PLE, and has removable terminal blocks. One thing to absolutely keep in mind is this 527 was designed to really be run only in a motion type mode. So you do have to have not only a safety controller to run it in a safety mode, but you have to have a motion enabled controller. And it only programs with Studio 5000. So that's a big difference, where the 755, you can run in a standard mode, you can program it, set it up, but the 527, you can only do that with Studio 5000. So the progression is, we had the hardwired safe torque off. We have, oh, I'm sorry, jumped a slide here. We had the S1 safe speed. I didn't really talk a lot about it. We could do safe speed in a hardwired and still can. It is a lot to set up, a lot of wiring, a lot of programming within the drive, setting parameters and such. So then talked about the S3. The very latest is the 2750 S4 card. And this card can do the safe speed, but do it over Ethernet. So key elements to see in this module is that not only can we do the same safe torque off or safe stop, safe ramp to stop of the S3, we now can do safety feedback interface, where we are feeding back from a encoder to know for sure the speed of the drive, safe brake control, safe limited speed, safe direction, safe limited speed position, separate safe stop, and then safe operational stop. So there's a ton of information on this out there in the manuals. I'm not going to dig deep on that, but just know that we can now do safe speed control via Ethernet with a GuardLogix or compact GuardLogix controller. And the same with this card, fine print. It is still CL3, PLE, Cat4. Same as the S3, no communication port on the card. It uses the internal 755's Ethernet port. You can make it on a device level ring if you add the dual port card. And modes of operation for the 755, both standard IO mode and step motion mode. For 755 right now, right now it's just standard IO mode. Same as S3, needs to go in port 4, 5, or 6. Or if you're running in a motion mode, can only go in port 6. So good to know there. And the reaction time of the unit, because you're doing so much more data processing, is typically less than 100 milliseconds. It does have some onboard I/O, 4 safety inputs that can be used, as well as 2 safety outputs. As I said, it's compatible with the 755 and the 755 T series, not the 753. This card, you need to be at version 14.002, firmware 4.001, and you can see the add-on profile versions are newer as well. And the controller needs to be at version 31 or later, which is a little newer than the S3 card, and the same with the controller compatibility. 5380 or 5580 safety controllers when using this card. You only program it with Studio 5000. You can monitor and look in at it from CCW or Connected Components Workbench, but cannot program it with this. And automatic device configuration is available for that as well. So now let's look at taking these devices and understanding that they can be included on your next IntelliCenter Motor Control Center project. Rockwell now offers some standard designs capable of easily integrating functional safety into an MCC. In the IntelliCenter Motor Control Center, there are safe drive configurations available. And if you're not familiar, the IntelliCenter is a motor control center that is completely networked. All motor starters, drives, and soft starts are controlled by Ethernet. You can literally run your motor power wires out, hook up an Ethernet cable, and you are ready to run from a program compact Logix or control Logix. There's more detail, a more detailed McNaughton-McKay YouTube video on this out there. So, please check it out. A lot of good information and value in the IntelliCenter platform. So Rockwell has taken this, and with these configurations, Rockwell has Systema files created to support drive safety. Systema is a free software that helps you figure out your safety system and what level of safety is required at your machine. So now, with very little cost added, you can have safety rated drives and contactors in your MCC. This includes the 2750S, S1, S3, and S4 cards that can be added, just not, like I said, not a lot of cost. And we can also add a PowerFlex 527 in the place of the 525 in a standard unit. It's a modification, but it's not a big ticket modification. So if you decided to order a drive unit with, this functional safety built in. It will be labeled just like the little drive soldier, on a 525 or 527 drive. It's labeled that it has functional safety. It goes through a verification and validation process, and the tests are performed and documented at the Motor Control Center factory before the order ships. And this is completed for every unit that has a sticker on it. So, you don't necessarily have to do it to every drive. If you had a fan or a blower, you may not need this, but if you had rollers or something like that, order it with safety built in. There is a document out at the Rockwell Automation Literature Library called, the document number is MCC-AT007B-EN-P. And this is the Centerline Low Voltage Motor Control Center's Functional Safety Application Techniques bulletin. So invite you to check that out and look at ways that maybe you hadn't thought about utilizing our drives in a safe configuration. So in conclusion, I just want to say thank you for watching. I hope you have learned a little more about the latest safety options available for PowerFlex drives and IntelliCenter motor control centers. At this time, I will turn it back over to Rachel.
Thank you, Lee. We do not have any questions in the chat at this time, but I'll give just a few minutes here for anyone that has any follow-up questions or anyone that's been waiting for this Q&A portion. While we wait, I'd like to remind you, you can always watch recordings of previous virtual lunch and learns on the McNaughton-McKay YouTube channel under the virtual lunch and learn playlist. And be sure to subscribe to our channel for more industry content just like this, and join us every Wednesday at noon for new topics. Les actually has a question for us here. In the picture with in the picture with the two boys, is Lee or Les the boy that is barefoot? Thank you, Les.
I would say that would probably be Les. He has a few years on me.
You guys are too funny. All right, I do not see any follow-up questions at this time. I'd just like to remind you all watching today that you can always reach out at the email address there on the screen, macandmaclive@nc-mc.com. Just be sure to reference the title of the session you attended so we can be sure to get your question to the presenter. All right, thank you, Lee, for a wonderful presentation. Thank you, Les, for being our resource and sense of humor out in the comment section. We enjoy presenting these sessions to you every Wednesday at noon, so be sure to join us next week on your lunch break. We hope that this session was informative and engaging for you. Again, please remember to subscribe to the McNaughton-McKay YouTube channel, and we look forward to seeing you live again soon. Thank you, everyone.